We will try to understand now what principles or what kind of properties do we need to look at for when a solute and a solvent mix and form a solution. This principle, or the, the slogan, if you will, of this whole trend is what we call like dissolves like, and that's what we're going to explain now. For, let's say that green is the solute and red is the solvent, what should happen when solute and solvent, for the solute and solvent to mix? Well, what should happen is that the green molecule should be able to interact at least as strongly with the red balls than with the green. And likewise, the red should be able to interact as strongly with the red balls than with the green. This is why we say that like dissolves like. Let me give you an example. If the green ball, say, that interacts with hydrogen bonds with the other green ball, and the red ball only dipole-dipole with the other red ball, because hydrogen bonds are stronger, even though they can, the red and the green can interact, the green ball would rather be interacting with the other green ball because they are stronger. Hydrogen bonds are stronger. So to find a common ground, solute and solvent need to interact with the same kind of interactions. In other words, this is what it means like dissolves like. A molecule that can show hydrogen bond will likely dissolve with another molecule that also shows hydrogen bonds. Otherwise, one or the other will rather be interacting with its own kind. Okay? So, just to put it into lines, let me read it out loud because it's important. When a solute dissolves in a solvent, solute-solute interactions and solvent-solvent interactions are being replaced with the solute-solvent interactions. The forces must be comparable in strength in order to have a solution. Okay, but like in chemistry, it's always to a certain extent. All right. Because there will be, you can always to some extent mix a solid with a solvent, the extent of which will depend on this like dissolves like kind of principle. The saturation point will be when you cannot add any more solute in the solvent. Okay, in that case you will say that the solute has reached the maximum solubility. Okay, so let's see if we understand this like dissolves like principle by solving a problem. In this case, it's asking us to predict which solvent will dissolve more of the given solute. So the solvent is water, and it's asking if water will dissolve better chloroform or carbon tetrachloride. If you draw the Lewis structure of chloroform, this has a dipole-dipole interaction. And in here, this is nonpolar, therefore you only have dispersion. Water, however, has hydrogen bonds. Notice that even though they are not quite the same, hydrogen bonds are similar in strength, not similar, but closer than dipole-dipole interactions, because, in other words, because water is more like chloroform than tetrachloromethane, it means that water will interact better with chloroform or trichloromethane. Okay, okay, let's do the second one. Again, we have the solvent water. Will it interact better with, let me see, 1, 2, 3, 4, 5, is that 6? Yes, hexane, or in this case, ethylene glycol. Oh, there you go, it's written here. Ethylene glycol has hydrogen bonds, and hexane, it's nonpolar, so only has dispersion. Again, water, because it has hydrogen bonds, it will interact better with ethylene glycol, so the solubility of ethylene glycol in water will be higher than hexane in water. Alright, and the last example is the solvent is ethanol. Okay, and you have, ethanol or water. Okay, you have two solvents, and is asking if diethyl ether will interact better or will dissolve better in water or in ethanol. Well, notice that this water is H2O, so it only has hydrogen bonds. Ethanol also has hydrogen bonds, but has an alkyl chain here that is similar to the alkyl chains of diethyl ether. Diethyl ether has a dipole-dipole interaction. It has a weak dipole, but in terms of similarity, ethanol is, in terms of intermolecular forces, is more similar to diethyl ether. So therefore, you can predict that these two will dissolve better than water and diethyl ether. These not as much.